All right, let's jump right into this explainer. Today, we're going to track a single fascinating thread of logic from the purely abstract digital realm all the way down into actual physical reality. We're looking at the exact magical moment when digital state reaches out and triggers a physical machine.
So we have to start with this foundational question. We usually just assume computers get us when we click a button, right? But bridging this gaping chasm between our messy, abstract human intent floating around in the cloud and the incredibly strict, deterministic world of physical machines, well, it's a monumental engineering mystery. Getting that to translate safely without the entire sequence just completely crashing is a massive challenge.
Here's our roadmap for figuring this out today. We'll quickly cover the digital-physical chasm, dive into the mathematics of perpetual state, explore decentralized ledgers, look at re-engineering the root, and finally, crossing the semiotic bridge.
Okay, Section 1, the digital-physical chasm. Let's look at how chaotic our traditional methods have been.
Think about traditional event-driven programming for a second. Honestly, it's incredibly messy. It's basically like setting up a chaotic set of falling dominoes. You get one delayed signal, or maybe an event fires twice, or the hardware falls even slightly out of sync, and bam, the entire sequence is totally ruined. And that is exactly why developers realized they desperately needed a new root-to-leaf architecture. A system that acts as a heavy anchor, demanding strict, bit-perfect deterministic execution with absolutely no exceptions.
Moving to Section 2, the mathematics of perpetual state. How do we actually achieve that flawless determinism?
Well, to build this flawless bridge, developers had to completely purge the old metaphor of a traditional upside-down directory tree floating out in the ether. In the source documents, they literally called this act apostasy. Pretty intense, right? But it makes sense, because you can't just float off in the digital void if you want to perfectly control physical reality. You have to be anchored. So instead, they anchored their system in pure continuous mathematics, which is beautifully represented here by a scale-symmetric fractal triangle used for non-halting architecture.
This whole shift brings us to a mathematical framework called Pythagorean metal. What this does is shift the guarantee of consistency entirely away from physical hardware, like, a hard drive spinning on a disk, and moves it to pure mathematical derivation. It treats the code, the action, and the data, the object, as isomorphic entities, meaning they share the exact same fundamental structure. It models them as a non-halting, self-reproducing automaton. So if a state is somehow lost, no big deal, it can be mathematically derived again, because every single coordinate is just a deterministic step in an infinite sequence.
All right, Section 3, foreshadowing decentralized ledgers. This is the exact point where deeply abstract mathematical geometry collided with real-world networks.
Check out this massive light bulb moment from April 2021. Researcher Kyle Smith sent an email mentioning he was exploring copyright NFT integration alongside IBM and Linux. This specific moment was the genesis of merging these incredibly advanced, theoretical, non-halting mathematical concepts with early real-world blockchain applications. The theoretical foundation was finally searching for a home.
And here was the critical realization developers had. This non-halting, forward-flying math was highly useful for the perpetuity environments of blockchain ledgers. Blockchains, by their very design, represent an unassailable, forward-flying arrow of time. So when you combine this self-reproducing automa with a decentralized ledger, you end up creating a state foundation that is mathematically pure, totally transparent, and permanently anchored.
Which leads us to Section 4, re-engineering the root. Let's see how they built a deployable anchor.
The ultimate culmination of all this research is a standard known as ERC 7827. It introduces this brilliant concept of value version control. Basically, it takes standard, lightweight JSON, the format we normally just use to zip text across the web, and it transforms it into a bit-perfect mathematical smart contract layer. It acts as a flawlessly anchored digital root, keeping everything human-readable while tracking every single state transition flawlessly on-chain.
So how does it actually maintain that bit-perfect control? It does it by recalibrating to a strict last-in, first-out, or LIFO architecture. This unlocks insanely efficient single-entry bookkeeping. Think of it kind of like a highly efficient bouncer at a busy club who only ever checks the ID of the person standing right at the front of the line. By only querying index 0, you get absolute mathematical proof of state instantly. You completely bypass the need to drag through massive, expensive transaction histories.
This index 0 check essentially acts as an ancient, unbreakable clay seal, just completely reimagined for the digital age. It gives you absolute certainty. A digital promise is either open or closed. There is zero ambiguity. The state is either mathematically true or it isn't.
Finally, Section 5, Crossing the Semiotic Bridge. Let's take that perfectly anchored digital route and travel all the way down the trunk to physical execution. Now, before any machine can actually move in the real world, we have to legally and practically ground it. The sources outline this framework called Cosmolo, connecting the high-level digital ether, the Cosmo, down to our physical local edge devices. First, a Kali wrapper is used to give real-world physical entities a legally binding on-chain identity. And then, once it's wrapped, a protocol called kernel sign tracks the actual physical human effort. It creates a permanent, verifiable record of sweat. I absolutely love that term. It grounds all that abstract cryptographic data right back into visceral, real-world human effort.
To orchestrate all of this seamlessly and affordably, the architecture relies on a multi-chain topology. The Flow network acts as this highly secure command registry. It stores the master JSON state and runs the main immutable loops. Meanwhile, Polygon steps in to handle the secure client portal and process these sub-second autonomous machine microtransactions using the X402 payment protocol. It really is a perfect pairing of structured execution with fast, cheap settlement.
And that brings us to the very end of our journey today, the literal, physical leaf node. In this specific implementation, it's the Cheerbot, which is a physical, Raspberry Pi-powered robot sitting right on a desk. This little machine receives those perfectly verified commands from the blockchain directly into its hardware pins.
Through this highly targeted surgical trunk of protocols, the perfectly verified on-chain code literally shocks the physical leaf node into action. It spins a motor. It turns on a light. Pure, abstract mathematical logic literally becomes electricity in the real world. It is absolutely wild when you trace it all the way down like this.
As the documents put it, the human pilot applies the intent, but the agent cell executes the sweat. That semiotic bridge, the one spanning the massive chaotic gap between our human desires up in the cloud and strict, deterministic machine execution, is officially and safely wide open.
So the biggest takeaway from this explainer is that this isn't just theoretical anymore. We've actually moved from abstract fractal geometry to a grounded architecture that can sit right on your desk and physically react. The technology is already here. So the only question left for you is when these bit-perfect promises start orchestrating reality in your own living room, what on earth are you going to program them to do?